All right. Today you're going to learn about part 2 of our notes. We're going to learn about the structure of the atom and how atoms are different from each other. So last time we talked about the history and we learned the postulates of Dalton's atomic theory, and that Dalton said that atoms of the same element were identical. Today we're going to talk about how they are actually different. So that part of Dalton's atomic theory was not correct. So we learned about the discovery of the subatomic particles yesterday. So now let's review. Protons are positively charged and they're found in the nucleus. The nucleus is the middle part. Neutrons are negatively charged. By the way, protons were discovered by anybody? Anybody? Yeah, you're talking amongst yourselves, thinking? Protons were discovered by Rutherford. Neutrons have no charge, and they're in the nucleus also, and they were discovered by James Chadwick. All right. Electrons were discovered by who? All right, that would be J.J. Thomson, and they orbit the nucleus. They have a negative charge, and they orbit the nucleus in the electron cloud. That's what we know it as now. This is a picture of the Bohr model. He had it with them orbiting them in this cloud that it orbited around the nucleus. So you've got a positively charged nucleus and negatively charged electron cloud. The entire atom itself is neutral because I have 3 positive charges here and I have 3 negative charges. They cancel out. Now, not all of them. This would actually be an atom of lithium. We'll talk about that more in a minute. So these are the subatomic particles. They have some symbols. So oftentimes you're going to see the symbol for a proton written as a P with a plus sign because it's a proton and it's positive. Neutron is an N with a 0 because it's a neutron, and the 0 is there because it has no charge. An electron is an E with a negative because it's an electron and they have a negative charge. So these are the symbols. When you see me write stuff down as I do examples, or sometimes I'll type it this way, these are the symbols you need to be familiar with. A nucleus is, the proton is located in the nucleus. The neutron is located in the nucleus. That's why these are called nucleons. They're particles in the nucleus. The electrons are found in the electron cloud. The charge of a proton is +1. It's got a charge of 1, positive 1. Neutron has no charge. An electron has a negative 1 charge. So 1 proton and 1 neutron will cancel each other out as far as their charge goes, which is really interesting considering the masses. Even though a proton is 10,000 times larger than an electron, they're in mass, their charge is the same magnitude or the same size, just one's positive, one's negative. So that's why we say the relative mass is 1 and the relative mass is 1. For a proton neutron, we say relative mass because they're so close to the same in their mass that we just say it's 1. We call that the atomic mass unit, or AMUs. The relative mass is 1. The electron has a mass of 1 times 1 over 1840. So it's actually 1840 times smaller than a proton. These are the actual masses. All of this was in the previous notes. So you have them written down there. You can go ahead and fill them in on this data table also. But there you go. Atoms of elements. Elements are identified by the number of protons in the nucleus of the atom. I told you earlier that that picture was an atom of lithium, and the way I knew that was because it had 3 protons. That is known as its atomic number. The atomic number is the number of protons. Number of protons equals atomic number. And if you look at the periodic table, the atomic number is what number the element is. So hydrogen is 1. Its atomic number is 1. It has 1 proton. Helium is 2. Its atomic number is 2. It has 2 protons. Lithium is 3. Beryllium is 4. Boron is 5. Carbon is 6. So on and so forth. So if you have 2 atoms, that have the same number of protons, then they are the same element, no matter what. If I have an atom that has 3 protons, it doesn't matter how many neutrons or electrons it has. If it has 3 protons, it is lithium. No matter what, that's what identifies it. So it's like the Social Security number of the element. If 2 atoms have different numbers of protons, they are different elements. So if this atom has 3 protons, it's lithium. If this atom has 4 protons, it's beryllium. So they are different. And the difference is the number of protons. So the number of protons is what identifies the element. That's why we can number all of the elements on the periodic table. They're ordered and numbered by how many protons are in their nucleus. The total number of nucleons, or particles in the nucleus, that would be protons and neutrons, are nucleons. The total number of nucleons is known as the mass number. So a proton and neutrons each have a relative mass of 1. So if I have 1 proton, that's a mass of 1, and 1 neutron, that's a mass of 1. So if those are both in the nucleus, then I have a mass of 2, because it's 1 plus 1 is 2. So you simply count up the number of protons and the number of neutrons, and that tells you your mass. The sum of the number of protons and the number of neutrons is what's the mass number. So the mass number of an atom is the protons plus the neutrons. So if you know what element it is and you know the mass number, then you take the mass number and you subtract the number of protons to figure out how many neutrons it would have. So your mass number is always going to equal the number of protons plus the number of neutrons. So that means your number of neutrons, right here, your number of neutrons will always equal your mass number minus your number of protons. And you know the number of protons by looking at the periodic table for what element it is. All right, since atoms are electrically neutral, meaning an atom itself does not have a charge, the particles that make it up have charge. So the protons are positively charged, the electrons are negatively charged, but the atom itself, the whole atom, is neutral. That means the total number of positive charges and the total number of negative charges cancel each other out. So that tells you that protons have a charge of +1, electrons have a charge of -1. So if the atom is neutral, that means the number of protons and the number of electrons in a neutral atom are always going to be the same. If they're not the same, then you have an atom that is no longer neutral. It's a charged atom. We call that an ion. And so you find the charge number by subtracting the number of electrons from the number of protons. So if I have 5 electrons and 3 protons, then I have 5, or I have 3 minus 5 would be -2. So I have more electrons or more negative charges, so I'm going to have a negative charge number. Charge number is always number of protons minus number of electrons. If my number of protons is bigger than my number of electrons, then my charge is going to be positive because I have more positive charges than I do negative charges. If the number of electrons is bigger than the number of protons, then my charge number is going to be negative because I have more negative charges than I do positive charges. So it's always protons minus electrons. It is not biggest number minus smallest number. It's protons minus electrons. All right. For a neutral atom, charge number is 0. So the number of protons and the number of electrons are equal. So in a neutral atom, if I have 5 protons, I'm going to have 5 electrons. And so that would be a neutral atom. Charge would be 0 because 5 minus 5 is 0. Now, remember, one of Dalton's postulates was that atoms of the same element were identical. This is not completely true. They are the same in the number of protons they have. So if I have lithium, I have 3 protons. All lithium atoms everywhere have 3 protons. However, they do not always have the same number of neutrons and electrons. So the atomic number identifies the element. So that's what makes it the same element. It's possible, however, to have atoms with the same number of protons, but different numbers of electrons and neutrons. So Dalton was not correct in saying atoms of the same element are identical, because we now know that atoms of the same element can have different numbers of protons or different numbers of neutrons. Sorry, I misspoke. Atoms of the same element can have different numbers of neutrons and different numbers of electrons. And we call these isotopes. Isotopes are atoms of the same element that have different numbers of neutrons, and therefore they have different mass numbers. So carbon has a couple of different isotopes, but carbon has 6 protons. If it has 6 neutrons, then it has a mass of 12. We call that carbon 12. But then you also have carbon 14 and carbon 13. These are different isotopes. So when you have it written like this, you have the name of the element and then is its mass. Now carbon has 6 protons because it's element number 6. So we know that it has 6 protons. So carbon, carbon, carbon. All of these have 6 protons. This one, though, has a mass of 14, which means 14 minus 6 is 8. So this one has 8 neutrons. 12 minus 6 is 6. So this one has 6 neutrons. 13 minus 6 is 7. So this one has 7 neutrons. So they all have 6 protons. That's what makes them carbon. But this one has 8 neutrons. This one has 6 neutrons, and this one has 7 neutrons. So they are the same element, but they have different mass numbers. That's what makes them isotopes. All right? They each have 6 protons, but one has 6 neutrons, one has 7 neutrons, and one has 8 neutrons. Again, these are all isotopes of carbon. That's what an isotope is. It's a fun word to say, isotope. All right, the existence of isotopes is why the masses on the periodic table are not whole numbers. When you look at the periodic table and you see the masses, they're all like carbon is 12.011, 6.491, something like that. So they're not whole numbers because if you're talking the number of protons and the number of neutrons, those should always be whole numbers, but they're not. And it's because of isotopes, and we're going to discuss that more in the part 3 of the notes about how we figure out those decimal numbers of masses. Ions are another way that atoms differ. You can have 2 atoms of the same element that have different numbers of electrons, all right? So they're going to have charges. Ions are atoms or a bonded group of atoms that have a positive or negative charge. So you can have positive ions and you can have negative ions. And that happens when the atom either gains or loses electrons from the electron cloud. If I have a neutral atom and I take electrons away, then now it has fewer electrons, and so it's going to be positively charged. If I have a neutral atom and I add electrons to it, then it's going to have more electrons, and so it's going to be negatively charged. So atoms do not lose protons unless a nuclear reaction takes place. We will talk about nuclear reactions next week. But right now, we're not talking about nuclear reactions. So atoms do not lose protons. So when we're talking about the charge changing, it's always the electrons that are changing, number of electrons. So a lithium atom will always have 3 protons. It doesn't lose those protons. It can lose electrons or it can gain electrons, and therefore it can become charged to become an ion. And so let's use the example of sodium here. Na0, the 0 means 0 charge. So sodium is 0 charge. It's going to have the same number of protons and neutrons. A positive charge means it has 1 more proton than it does electrons. But again, it doesn't lose or gain protons, so that means it lost an electron. It lost a negative charge. Na with a -1 would be where it gained a negative charge because now it has 1 electron more than it has protons. The protons don't change, so it would be the electrons that change. Now, this is not actually a possible thing in the real world, so this is just used for an example. So they're all sodium. They all have 11 protons because sodium is number 11, but one has 11 electrons. That would be this one. 11 protons, 11 electrons, charge of 0. Protons minus electrons. One of them has 12 electrons. So if I did protons 11 minus 12, 11 minus 12 is -1. So this one has 12 electrons. And then one of them would have 10 electrons. 11, the number of protons, minus 10, the number of electrons. So 11 minus 10 is 1. Positive 1, there you go. So remember, the charge number, that's what this number is up here. The charge number is always the number of protons minus the number of electrons. So we have 11 protons minus 10 electrons gives us a positive 1. Really wish that this didn't pop up all the time. All right, there are two forms of ions, as we just discussed. There are positive ions that have less electrons than protons, and you have positive ions are called cations. I want everybody to look at that word and listen to how I say it. Cations, not cations, not cations. It is cation, cation, cation. I'm going to say it over and over and over because I get tired of people mispronouncing it. Not cations, not cations. If you say that, I might just look at you with a dumbfounded look on my face like, huh? Because, well, you know, I'm telling you, they're pronounced cations, all right? Negative ions are atoms that have more electrons than protons. So if you have less electrons than you do protons, so if you have more protons, it's a cation. If you have more electrons than you do protons, so more electrons is called an anion. A negative ion is an anion. All right, so if you have difficulty remembering which one is positive, which one is negative, cations has a T, and T looks like a plus sign. Anions has an N, which is the first letter of negative. It's not the best way to remember it, but hey, it helps. So go with it. Now, there are two main ways for representing the information about an element when we're looking at it. We have what's called isotopic notation, talking about the isotope. That uses the name followed by a dash followed by the mass number. You saw that earlier when I was talking about isotopes, and you saw the carbon 12, carbon 13, carbon 14. So example here is uranium-238. So the element is uranium, which has 92 protons. 238 is its mass, which means it has a lot more than 92 neutrons, right? So isotopic notation is the name followed by the dash followed by the mass. Symbolic notation uses the element symbol and numbers in certain places to identify the important information about the element. So let me show you what that looks like. So symbolic notation is going to look like this. You're going to have the symbol. So we have iron. That's the one I'm going to use. That's the symbol. Remember, the symbols are always a capital letter and a lowercase letter, or just one capital letter. Then you have the atomic number. The atomic number is going to be written as a small number down here on the bottom left. Then you have the mass number, which will be written in the top left. And then you have the charge number, which would be written over here. Now, if the charge is 0, we don't write it. So if there's nothing written here, then it's a neutral atom. So what this means is I have 26 protons, because that's the atomic number, 26 protons. 56 is the mass. So if I want to find the number of neutrons, it's 56 minus 26 would be 30. So this has 30 neutrons. And the charge is plus 4. So if my charge number is my protons minus electrons, then 4 equals 26 minus something. Well, that would be 22. So this has 22 electrons, 26 protons, and 30 neutrons. So we can use this notation right here and those equations I gave you earlier to figure out the number of protons, neutrons, and electrons. And that is some of the stuff you're going to be doing on your assignment. So go back through and look at those equations, and good luck.